Hello everyone. So today we are going to continue with the LOD system for our planet generation. So here, this is the preview. If I play from here, let me enable wireframe mode. Now you can see some polygons are increased around the character. If I detach from the character and the character, and if I enable the wireframe mode, you can see compared to the rest of the planet, the characters in the area where the character is has a higher polygon count. So if I move the character manually, maybe somewhere like this, now you can see polygon count increases like this. So yeah, this is what we are going to work on today. Based on the character location, increase the polygonal count or increase the level of detail of the planet landscape. And before we get started, I'd like to remind you, you can download the project files of this project and all other thousands of projects that I have done in my channel. To the date, there are over 1800 videos. For each video, you can access the project files. For the membership of the Patreon page, I'll leave the link in description below. And let's get back to today's video. So yesterday we worked on this initialize 3D grid function, which creates a grid around this planet so that we can divide the surface area of the planet surface into cubes so that we can use that to implement a LOD system, so or level of detail system. Okay, so that's now what I'm going to continue with the LOD system. Now that we have a way to determine the surface area and determine which part of the planet mesh belongs to which grid cube. So first I'll call this initialize 3D grid in the begin play, and here I have the 3D grid map variable so that all the 3D grid data is saved in there. Then I'll add another event to update the LOD. So let's add a custom event. I'll call it update LODs loads. And now we should only update level of details if the planet is the closest planet, because this is determined if the player is currently in this planet, then only we should worry about updating the level of detail. Otherwise we can just ignore and leave it as it is. Okay, so now the next step is we need to determine, let me show you again, which cube the player is currently in. So then we can get the mesh section or the polygons that belongs to that cube and increase their level of detail. So for that, I think I would need another function. So I'll call it get LOD cube. Okay, and here, so we have this 3D grid. From this 3D grid, I can get keys, and let's promote this to a local variable. Let's call it keys, and then values. Let's also promote that to a variable, a local variable, values. Right, and then let's iterate through these keys. It's enough for each loop. So what we need is to determine the closest grid cube that we need to update. So I might need another variable. I'll call it closest distance, and this should be a float, and I'll put a very large value for this, something like this, so that whatever the first value we get would be smaller than this. And then also we might need closest point index, not actually point, the cube, because 3D grid we have cubes. Okay, now here we can get the distance from this point to the player. Now one thing here, I'll add a new function, get player location. The reason that I implement this as a new function is because we might have either player or we might have a pawn. We might either have a character or a pawn. Otherwise we can check get player pawn, because when we have the spaceship, that's a pawn. So is valid if yes, we can get actor location and return its location. Otherwise, if we don't have any of them, I'll just return 0, 0, 0 location, and I'll make this a PO function so that we don't have to connect it to this one of these execution flow lines. Alright, now here we have the distance, and we can check if this is less than the closest distance. This condition should be true, and also using this index we can get the value. So as I said, this grid 3D grid value, this is an integer, this represents the current LOD level. So when I initialize it, I didn't actually think about it. Here I add 0, but usually LOD levels, as 0 is the highest level of detail, and 1, 2, 3 like that, we have the, as the number goes high, the level of detail is usually low. But for this, I'll consider 0 as the lowest detail, or whatever the default level of detail value, and I'm planning to have only 2 level of detail levels. So here, where is the function? Yeah, we are still working on here. From this I'll get a reference using this, and we need to check if this is less than 1. Let's check if this is equal to 0. So that means the level of detail is not updated yet. Also, this distance should be within the radius that we consider to update level of detail. So for that, I have this grid cube size. Maybe let's consider twice the size of the grid cube as the area that I need to update for the level of detail. When all these 3 conditions are true, I'll consider this point as a candidate to update the level of detail. Okay, then I'll update this closest distance as this distance, and the closest cube index as this index, right? And I'll use the default value closest cube index as 1, so that we know if we haven't found a candidate to update the load, then we can use that. Alright, now here let's set a branch, and get the closest cube index, and we can check if this index is a valid index for these keys. If yes, we can return this key, get a reference using this index. So this would be, well, yeah, this would be the center of the cube. So cube center, and also I'll return cube center index, sorry, cube index. I'll just call it cube index. And also we need to give the current LOD level. Well, do we? Not really. I don't think we need it. Alright, and I'll consider this, convert this function also to a pure function. Then let's go back to the here, and let's drag and drop this get LOD cube, and let's check if this is again, wait, I'll add a bool update LOD, and I'll return true here, otherwise I'll return false. Right now, here, if this is true, we have to update LOD level of the cube that is represented by this cube center. If this is true, now also we need to update in this 3D grid. Let's add 1 to this grid center so that we have marked as this cube area, the level of detail has been updated, so we will not try to update it again. Okay, now that we know the center of the cube, that we need to update the level of detail. So the next step is from we need to get the dynamic mesh component, get dynamic mesh, and from here we can select mesh elements in the box. So I'll select vertices, and we can define the box like this. Now we have the grid center, so but this is in world space. We have to give this location in relative space. So let's add a new scene component, LOD point, and then I'll set world location of this LOD point using this cube center like this. Then here, now I can get the LOD point and get relative location of that. And now we need to add and we need to subtract from this point to get min value and max value that defines a box with this grid cube size. So we have to divide this by 2 because we only need the half the size to get the extents. Right, now this first one would be min, second one would be max. All right, so we did a lot without really testing. I think we should do some testing. Draw debug box. This is only for testing, but here we only need to use the world location of the LOD point. Get world location. I'm just gonna draw a cube just to see we have the correct LOD point for 5 seconds. So if this part is correct, we can then move on to updating the LOD. So the extent would be this. This have to be something like this. Okay, but we are not calling this anywhere yet. So where should we call this? Here in the begin play, let's call timer by function name. Of course, set timer by function name, and the function name is update LODs, and I'll call it in every 5 seconds looping. Okay, now let's start from somewhere here. Now in 5 seconds we should see a blue cube. Do I see it? No. Let's add a print also, updating LOD, so that we can make sure this function is being called. And also initialize 3D grid. Here I keep this for 10 seconds. I'll skip this draw debug box because I only need to one debug box now. Did it call? No. Let's debug this. And see if this is actually being called. It is. Oh, it's always going here. Why? Let's check the 3D grid. No, we can't check that. Can you check the values? No. Here everything is 0. Okay, so this is not correct yet. Here we don't see it's going here. Oh, here I have a problem. This should be not closest cube index, this should be closest cube distance. Really sorry about that. Now let's test. Yeah, we got the update in LOD cube, but okay, right, here we go. We have the cube, but it looks a bit not exactly the cube that we are in currently. I can test it. I'll increase the duration of the cube kept in the level. Then let's land somewhere like this and eject. So yeah, actually it's correct. You can see where is our character. Yeah, it's correct. Oh wait, I think here when I come to this step I have already updated this, so this is called effectively called again, which is not good. So I think I should have converted this to a variable. So let's promote this to a variable and let's continue to use that. LOD cube center. No, we don't really need to do that. What we need to do is interchanging these two steps. That means this should go here. Now here, if I start playing over here, I should see, so that's the regular grid. I should see in blue the closest grid that I am currently. See, it's this one, correct, and the next one. So that's how I would be updating the level of details. Okay, now that we have a way to select the cube, next step is actually increasing the level of details. So for that, okay, here we select mesh. We don't need this. Here, let's collapse this to a subgraph. This. Well, I am only using this part to draw the debug box, so let me just remove that. I don't really need it, and let's collapse this entire area. Update LOD. Now we have the target mesh. So let me take a look at the initial way I rebuild the mesh. So here I do apply a selective tessellation and add a Berlin noise, but for LOD level we need only micro scale detail changes. So let's go back here. I'll add a tessellation and I'll give this selection. Tessellation level maybe just 3 should be enough. Let's start with 2, and then using this I also have this planetary Berlin noise. Let's add a planetary Berlin noise, but here I'll use a lower scale magnitude, because as we add more details we don't really need it to have like new mountains. We just need to refine the details that we already have. So frequency so should be 8.5, and we don't need to randomize target mesh like this. All right, let's test now. Let's go here. Where should we test? Okay, over here. Now you see you have this. Well, we can actually see the detail changes in wireframe view. Wait, I think I should disable the debug cubes, otherwise it's not clear. Right, happened to the mesh? Oh, it was compiling. Okay, let's test. So here now see, did it increase the poly count? I think so. Let's hover above. Okay, see, it did increase the poly count, and it increased over there as well. So yeah, now as you can see here the system is working. Why is it getting stuck? I think it continues to divide. Why is that happening? Continues to subdivide for some reason. I think using just one here. Why is this changing? Maybe we can just exclude this and use only this part. So only if it within the grid cube size it should update. Or just to be on safe side, let's have something like 1.2. And there is one small detail we overlooked, which is here I have select elements, and for the options when I apply selective tessellation I have options. and if I split this, options empty behavior. So if this selection is empty, what should we do? I should keep empty selection, not full mesh selection. So that should otherwise I think it applies the tessellation. If I don't have a selection, it applies the tessellation to all the planar, which increase the poly count of the everywhere, and it makes a expensive operation. And also when I apply poly noise here, I haven't passed a selection option, so I let that now. And here also, well, actually I never had the option passed into here anyway, so it was always applying a full mesh selection and apply poly noise everywhere, which is already expensive. Now that I have this, I can, let's go back, we can pass the selection now like this. Okay, compile and let's test here. Okay, so now you see this area becomes smoother. Let me eject from the character. The character now over here, and if I go to the wireframe mode, now you see the area around the character has increased the poly count like this. Okay, now let's check here. As I move around the world also, let's test. Here you can see the poly count is increased. If I speed up and move further in the world, now you see poly count increases over there. Yeah, so it's working. So I think we can stop this episode right here, but this is still no way perfect, no way finished, so I will have to continue to work on this system for some time and to get it right, but I hope I'm making progress. So thanks for watching. As always, updated project files will be available for the download in the Patreon page. Link would be in the description below, and don't forget to like and subscribe. See you in another episode. Goodbye.